welcome everyone this morning to another session here of the Strategic Farming Let's Talk Crops webinar series. Again, this is sort of a unique series that we have a little bit of a presentation, and then we have a substantial amount of time for discussion. So for today's topic, we wanted to address integrated weed management and some of the tools beyond chemical control that we can help integrate into our systems and can help manage weeds. And so our focus is really going to, well, we might mention some chemical tactics and strategies. Our focus is really going to be to talk about some of these other tools that might be integrated and what sort of role they may play in helping to manage weeds. And so that's kind of the concept for today. And I want to thank Extension as well as Minnesota Corn and Minnesota Soybean for their sponsorship today of the program. I'm Ryan Miller. I'll be moderating things for today. As you develop questions, as we kind of do this first 30 minutes or so of presentation, feel free to enter those in the Q&A box on your screen there. You can jump down and type in a question. By chance, if you need to raise your hand and ask it in person, I think we could probably try to make that work too. But if you just want to type your questions in, we'd appreciate that. It can help kind of guide the discussion as we proceed today. So we've got three presenters with us to help facilitate the discussion. We've got Debalin Sarangi, a weed scientist at the University of Minnesota, working in corn and in soybeans, and he's going to kind of start our program off today. And then we've got Eric Yu, a recent graduate from Dublin's program. He did some work with cover crops and how you might integrate cover crops into an integrated weed management program. And so Eric has joined us today. He's now actually joined our crops team as a crops educator with the rest of us here. Located in Farmington, our regional office there, just south of the metro. And then last but not least, we've got Tom Peters, weed scientist with North Dakota and Minnesota, working in more of the sugar beet systems or sugar beet driven systems up there in the Red River Valley in West, where we have a lot of sugar beet production. So he's got a long experience with weed and weed management, and so we look forward to his expertise today. And so with that, we will get started. And Devlin, I think you're going to kind of start with a little bit of a discussion on how we're in a situation where we seem to be running out of chemical weed control options, and we really need to think about preserving the tools we have left for our farms. And so with that, we're going to switch it over and let you start the show.
Thank you, Ryan. Thanks for having me. And good morning, everyone. Thanks for joining today. So I'm going to share my screen. I have just few slides to talk about. Um, we are getting a lot of questions about water hemp and its situation right now in Minnesota. Like, are we getting some new resistance, and what's going on with all the resistance that were reported before? So, my graduate student from 2020 to 2022, he finished this survey. So what we did is we collected 90 water hemp populations from 47 counties in Minnesota. And some of the populations were submitted by the growers because they suspected something is going on in those populations. Some of the samples were collected by my grad students. And what we did is we tested those 90 populations against 8 different herbicides like Raptor, Enlist One, Extenimax, Atrazine, Roundup, Liberty, Flexter, and Callisto. So when we tested them, we got to see what is going on with the resistance level in those population. And recently we published that paper in Weed Science Journal. So so here is the result for that from that survey. So I'm breaking it down with this pie chart. So 2,4-D if there is orange slice in that pie chart, that is the highly resistant population. So out of 90, 6% were highly resistant. And if it is yellow, those are like 4% populations um, out of those 90 populations resistant to 2,4-D. And then the blue chunk is that less sensitive. That means there are some individuals in those population that were resistant to 2,4-D. And then the green one is the sensitive one, like it still can be controlled with 2-point rate of enlist one. So if we combine that orange and yellow part, so 10% population that were resistant to 2,4-D. So that means out of 90, like 9 population, and more than half that were already less sensitive to 2,4-D. So similarly, if we move to atrazine, about half of those populations were resistant to atrazine, and 31% that were less sensitive to atrazine. Dicamba, we spread XtendiMax, and 2% that were resistant to dicamba, and about half of those populations were less sensitive to dicamba. Fomizafen, about like Flexter, I'm talking about, 31% resistant to Flexter, and 26% less sensitive. Glufosinate, there is a good news because none of our population came out as resistant to glufosinate or Liberty. And we have to save this option because looks like this is one of the options still working for water hemp in Minnesota. But the concerning news is 22% population that showed the less sensitivity to Liberty. So those population had the potential to grow as a resistant in the future. Roundup and Raptor, pretty much like Raptor is the Imazamox and Roundup is glyphosate. Pretty much everything that was resistant to Roundup and Raptor. And then Callisto, about 22% population that were resistant to Callisto, that is mesotrione. And 58%, more than half of those population, shows some sort of reduced sensitivity to Callisto. So that's already a concerning news for us. And then when we combine that information for different herbicides for individual population, we came out with this graph for multiple herbicide resistance. So that means one population resistant to more than one herbicide sites of action or herbicide chemistry. So here in this graph, so x-axis has all the herbicide combinations, and y-axis has number of populations. So Imazamox, which is Raptor and Roundup, like 25 populations resistant to Raptor and Roundup, 18 population Raptor, Roundup, and atrazine. So like the level of multiple herbicide resistance is kind of increasing in that order. But if you look here in the middle, right, there are two populations that were resistant to Raptor, Roundup, Atrazine, Flexter, Callisto, 2,4-D, and another two populations resistant to all those, including dicamba. So that's the concerning news because these are all the 6Y resistant population, and only herbicide works to control these populations is Liberty. And remember, these populations were tested against the post-emergence herbicides, right? We spread foliar application herbicides and we tested them for resistance. These are not anything about pre-resistance, right? And this is the quick distribution. I'm not going into that. And let's move to this thing. So, okay. So, if the herbicide resistant weed problem that are addressed with only herbicides, the evolution will most likely win. That means we need something else apart from herbicide to help our herbicide. So, my first question for you, how can we help our post emergence herbicide? Because I showed you those populations were resistant to post-emergence herbicides. So first thing is pre. If you start clean and stay clean, maybe that is one of the good approach. So on the left-hand side, you can see this cornfield that didn't get any pre-emergence herbicide. And on the right hand side, this field got some pre-emergence herbicide. So now compare them. So the corn growth is better, yes, but look at the weed pressure in no pre situation. Now, when you come back with a post emergence herbicide, that will have really hard job to control all these weeds because they're dense, they're tall. So the post-emergence herbicide will not be really effective. Maybe you will get 50, 60, 70% control, but not the 95% control. And we tested in a long, like in a 3-year study in Rosemont, Minnesota, that if you have a pre versus like some sort of pre, like let's say warrant type pre, which will give you like 80, 90% control. And if you have no pre, the average yield gap between those pre and no pre is 11 bushels per acre in soybean, I'm talking about. Now, yes, pre-emergence herbicide comes with some challenges like drought. If you have dry condition, that pre-herbicide will not be activated, right? And another situation is like too much rain. Like this is the picture from 2024. We got too much rain in the spring and we spread fierce easy, which is flumioxazine and pyroxasulfone. And you can see the soybean injury on this field, right? In this field, but we tracked the yield. There was no yield difference between this field and an adjacent field that did not get the fierce easy. But yeah, I mean, there are some challenges with pre's. So next thing is row spacing. If you grow your crop in a narrow row, maybe the crops will be more competitive by closing the canopy earlier. Remember, water hemp emerged from starting from May up to early August. So if you close your canopy earlier, it will dark out and there will be less sunlight reaching to the soil and less germination of water hemp in the late season. So this is the picture. On the left-hand side, we planted soybean in 12-inch row. So those white spots, those are soybean plant, and the black area, those are the soil, bare ground soil. And on the right hand side, this picture is showing this soybean is planted with 22-inch row. So even not 30-inch, like 22-inch. But what is the difference you can see? So after 50 days of planting, the 12-inch row had 62% canopy cover, whereas the wide row, which was 22-inch, had 38% canopy cover. So that is like 50% reduction when you go from 12-inch to 22-inch. And on the this graph is showing like x-axis has the GDD, growing degree days, and y-axis has the ground cover, right? So we put a line at the 90% cover, and we found between 12-inch and 22-inch there are 2 weeks gap. So 2 weeks gap just to close 90%, like get the 90% canopy closer between 12-inch and 22-inch row. So last slide before I hand it over to some other speaker, that maybe you can make your crops more competitive by planting earlier. So this is the picture from Rosemont, Minnesota in 2024. So on the left-hand side, this soybean was planted on May 1, the same variety, May 15, the same variety, June 1st. So now you can see there is clearly so this picture was taken on July 10th. And you can see there was a clear difference in their canopy growth and canopy closure. And when we took the yield, we saw there was significant difference. Like the May 1st planting had about 62 bushels per acre. May 15 had about 59 bushels per acre. And June 1st had about 50 bushels per acre. So there was clear difference in their yield as well as their canopy growth. So I'll probably stop here and I will let other speaker talk about other tactics.
All right, so Eric is on next. Eric, do you want to try sharing and see if we can get your slides to full size here?
Uh, yeah, so I just wanted to highlight today a study that I conducted while I was a student with Debalin, and looking at cereal rye cover crop for optimal weed control and soybean yield. And I just want to quickly just give a little background before I jump right into the results to kind of set up the project. This is a conceptual graph from Cates et al. 2018, derived from a paper from Finney et al. 2016. So we have the benefits along the y-axis and then cover crop biomass along the x-axis. And I just want to highlight two of the benefits, including weed suppression and cash crop yield. So we can see that as biomass increases, that weed suppression uh, it does increase in terms of its benefits, but there is a plateau. So you're getting diminishing returns after a certain point. And then if we look at the cash crop yield line here towards the bottom, we can see that there's a slight increase in yield, but then it dramatically drops as soon as that biomass gets to be too much. Now that biomass is predicated heavily on when you terminate your cover crops as well as your seeding rate. So what are the current recommendations? In Minnesota, we fall into zone 3 and 4. So that termination recommendation is going to be at or before your cash crop planting. Or it's even before that cash crop starts to emerge. And then for your seeding rate, currently the recommendation that's printed online is 50 to 55 pounds per acre for incorporated seed for cereal rye. Now I was made aware recently that minimum was reduced down to 40 pounds per acre if planted before October 1st. After October 1st, that recommendation does go back up to 50 pounds per acre. But these recommendations they're not substantiated in terms of its optimal biomass accumulation in Minnesota. So the objective of our study was to evaluate the impact of cereal rye seeding rate and termination timing on weed control and soybean yield. So we had two study sites, one in Lamberton, Minnesota at the Southwest Research and Outreach Center, and then as well as a farmer's field near Rochester in Eota, Minnesota. And we actually had 2 years of data collection in 2022 and 2023. And the system that we looked at was in year one, we planted corn for silage and harvested that. And then immediately followed with fall seeded cereal rye. And then the following year, we did soybean planting. Looking at the treatments real quick, we have soybean planting date at May 15th, which we designated as the early planting date, and then June 1st as our late planting date. Our June 1st date was to allow for more biomass to accumulate to see if there was a way to kind of compensate for that late planting and have more benefits from the cover crop. And then our cereal rye, the variety we used was ND Gardner, which is an early maturing variety. And we had four rates that we looked at. Our 0 pounds per acre was our control, and then 60, 90, and 120 pounds per acre. We did go kind of above that recommendation to overcompensate for some of the inherent challenges that we have in Minnesota, such as that short planting window and just the cold winter that we experience here. And then for termination timing treatments, we had four treatments here. We had 7 days before planting, at planting, at planting with a pre-emergence herbicide. So here, that pre-emergence herbicide was Verdict, and then 7 days after planting. So all of these treatments, we were using Roundup to terminate our cover crop. There's a lot of moving parts in this study, so I just wanted to give a quick timeline to show the setup for the study. So in year one, in May, we planted corn for silage, and then around mid-September is when that was harvested. Immediately after, we did plant that cereal rye, and then the following spring, we planted the early soybean planting in mid-May, and then early June, that late soybean planting with soybean harvest for both plantings done in mid-October. Looking at the results, so we found that cereal rye seeding rate did not impact cereal rye biomass. So based on just our treatments, 60, 90, and 120 pounds per acre, we just didn't see that there was an additional benefit of increasing that seeding rate. Also, cereal rye biomass increased as termination timing was delayed. So this figure here just shows the amount of biomass that's accumulating as time goes on. So we'll look at this next table to kind of see what those numbers look like.
Eric,
Oh, yeah.
do you want to just take a second and explain how the rye was seeded? If you aerially seeded it, drill it.
Right. Yeah. So The rye was drilled in the uh, fall, and I believe the spacing was about 7.5 inches at about 1.5 inches in depth. So, um, and yeah, all done in the fall. I believe around early early October, late September was kind of our around the time that was planted. And then just to kind of look at this figure, the next slide kind of goes over what those numbers look like. Let's see. So our height, we peaked at about 46 inches to 57 inches, depending on the location here. It's pretty high. So that timing for late planting, 7 days after planting, was around June 8th. So it is pretty late. And then we were getting about 6,000 pounds per acre in Lamberton and about 6,700 pounds per acre in Rochester. And at least for the early planting, if we waited 7 days after planting, which was about May 22nd, we're getting about 30 inches of cereal rye, which equated to about 2,600 to 3,000 pounds per acre. Looking at the weed control and soybean yield data, for the following slides, I'm focusing just on the Lamberton location, but for both locations, it followed a similar trend. So weed biomass, there was a so along the y-axis we have weed biomass reduction as a percentage, and along the x-axis we have cereal rye biomass in pounds per acre. In general, we do see an increase in reduction as that cereal rye biomass increases, uh, but we're getting about complete reduction around 4,500 pounds per acre based on the study. And if we look at where 4,500 pounds per acre is landing with the study that was conducted, we're not achieving that biomass until we reach about that 7 days after planting or at planting of the late planting. So not until June. So we're not getting that high of biomass in terms of where we want to be with the early planting. If we look at water hemp control with the study, we can see that uh, with the early planting in general, we're not getting as good control as we are with the late planting. And here, just below the x-axis, we can see what the amount of biomass is associated with each treatment. And we can see that 7 days before planting, we're only getting about 380 pounds per acre of biomass, which is equating to about 40% control. So still some control, but not the control that we're kind of looking for. And then if we're looking at early planting, we're looking at about 80%. That does increase to about 90% when you add a pre. But interestingly enough, we're getting similar results with no pre 7 days after planting. So this is about 2,600 pounds per acre. Now looking at the late planting, we're getting about 80% control with water hemp at 2,900 pounds per acre. We're getting a little less control compared to that late planting is because of that Roundup application as well. So that's going to be a big factor in terms of our control as well. And then our late planting, at planting application with or without pre and 7 days after planting, we're getting like near complete control with our water hemp, but that's also like at 3,700 pounds per acre to 6,000 pounds per acre of biomass accumulation. Now with our grasses, so this was our most dominant grass species in this study, which was yellow foxtail. We're also seeing some of the best control in our early planting at planting with the pre and 7 days after planting. As far as our late planting goes, we're getting pretty good control, about 95% across the board. Now looking at the soybean yield, we're seeing that it's better to plant that soybean early. And the best soybean yield that we're getting is at planting with the pre and 7 days after planting at about 60 pounds per bushel. So the take-home message from the study was that seeding rate did not impact biomass, weed control, or soybean yield. So 60 pounds per acre is recommended, especially if you want to cut those costs. And then 4,500 pounds per acre provided complete weed biomass reduction. Weed control was greatest in the late planting. At planting with the pre and 7 days after planting, termination within the early planting still provided adequate control at above 86% control. And then soybean yield was greater when planted early. Yield was greatest at planting with or without a pre and 7 days after planting. So just the take-home message is that it's recommended to plant the cereal rye at 60 pounds per acre. Plant the soybeans early and either terminate the cereal rye at planting with a pre or 7 days after planting if not using a pre. This isn't a one-size-fits-all recommendation, so this is just a starting point for growers here in Minnesota. Uh, you're going to get a lot of variation depending on where you are, even within Minnesota. So geographic location matters, and then your management practices. So this is just a starting point and something to consider as well as how low can we go below 60 pounds per acre if that seeding rate didn't matter in this study. So that's something that we don't know here in Minnesota, but it's something that will be looked at in the future. Just a quick last thing, I just want to highlight a study that was done back in 2020 in Lamberton that looks at whether or not cover crop planting date matters. So this was from a crop news article written by Liz Stahl and Axel Garcia. And we can see that along the x-axis is when the planting was done. So we can see that if that planting is done within the month of September, especially earlier in September, we're getting a lot more biomass if in comparison to waiting till October. So if you can get that cereal rye down earlier, it's much better. So with that, that is all I have for my stuff.
Eric, a couple quick questions here. There was someone interested. Did you calculate live seed per acre with your cover crop application rates or just pounds per acre?
Right, so just pounds per acre for this study.
Okay, that's something you could always go back
So
and
I'll just make a comment
Oh,
that we used the ND Gardener, which is one of the variety developed by NDSU cereal rye, and I think that variety has 98% winter survival. So we expect like and we saw that like it is pretty good variety to survive in Minnesota condition. So yes, we did not count the live seeds or we did not consider that thing. We just went with the pounds, but we knew that winter survival is pretty good because a lot of people have questions about it in the past. Like Devlin, if you plant it in 60 pounds, what is the winter survivability of those rye?
yeah, and you guys, that variety too is known to be decent at stooling out or kind of covering the ground. So that's another benefit of that one. So anyways, good discussion on that. Um, let's see here. I think we're just going to take a second. Oh, wait, one last question on this, Eric. So we'll take care of this one quick. When you put your pre down, was there also a Roundup application?
yeah. So for that treatment, at planting with the pre it was tank mixed. So it was all mixed together when we applied it directly onto that cereal rye for termination.
Excellent. So I think now we're going to pass the baton again to Tom, and he's going to discuss a little work he's done with another kind of unique weed management tactic. So, Tom, take it away.
Thank you, Ryan. I don't have any slides, so I'm going to just talk. I'm going to talk about using electricity to control weeds, electrocution. So, this is something that is not a new idea. Back in the 1980s, there was a machine called the Lasco Lightning Weeder. So, there might be a few on that remembers this machine. Somewhat dangerous to operate, lots of repairs, but it was something that farmers that were growing low growing crops like sugar beet or soybean were using. So let's fast forward. So in the last 5 years, a company from Missouri um, Sedalia, Missouri, has developed a machine called the Weed Zapper. Okay, so it's very similar to the Lasco Lightning Weeder, although it's a lot safer to operate and it brings a lot more killing capacity to the table. So, how does it work? Well, essentially, you're pulling a generator. I think there's enough electricity to light a small town that you're pulling behind the tractor and generating off the tractor's PTO. So the first thing is you need a good sized tractor. You need 175 to 225 horsepower to run the generator. So you're producing electricity that's transferred through a bar. And when your weed species, and let's talk about water hemp as an example, when the weeds touch the bar, the electricity passes through the bar into the weed itself, and the temperature, the heat that is created destroys the integrity of cells, and essentially you have a series of mini explosions occurring at the cell level that immediately wilts the plant. That's the first thing you're going to see. Within minutes of application, you're going to see wilting of water hemp. Over the next couple of days, you're going to start to see necrosis or browning of the tissue. And the important part here is how good a job did the electricity do at moving through the weed species. If if you have good conditions where there's moisture in the water hemp, it's possible to get the electricity to move halfway, maybe even 2/3 of the way into the stem itself. And that will translate into good necrosis that will kill those portions of the plant. The limitation with electrocution is that weeds like water hemp are very good, they're very well adapted at reestablishing their growing points. So if you eliminate the terminal growing point, they'll start to branch laterally and they'll start to grow from below. And what I've seen in my work is electrocution is not a standalone program, but it works very well in an integrated program where you're using maybe other pre-emergence or other post-emergence products and using the electrocution as a way of killing or eliminating any weed escapes. So a couple of other details, Ryan. Of course, the weeds have got to be above the canopy. So if your machine touches your sugar beet or soybean canopy, you can cause some injury. You can potentially kill some plants. So that means you might have to operate this machine several times during the growing season since weeds are continuing to grow. Next thing I want to say is we've seen some regrowth that occurs. So we see the wilting, we see necrosis 30 or 45 or 60 days out. It's possible to see regrowth occurring, and to some degree, what looked to be very efficacious weed control early on isn't as strong later on. But one of the things that I really like about electrocution is that it reduces the viability of any seed that's produced. So for the pigweed species or weeds that make seed 14 days after you see a flower, being able to reduce the viability 60, 70, 80%, I think is a real important feature of this concept, this idea. How about other weeds? Well, it's not as effective on kochia and grasses as it is against water hemp. And the reason is is water hemp has a very clearly defined main stem, and it's a nice conduit for electricity to pass. Kochia, which is more branched, and grasses just we don't see the movement of electricity as well through those plants. It also takes a lot more horsepower to work on those weeds. And I've seen, I guess, inconsistent at best results on grasses and kochia. I think if kochia is important to you, you've got to be committed to using the machine maybe 2 or 3 different times to keep the kochia back. So, Ryan, that's what I want to say about electrocution, and I'll take any comments that are in the chat.
So, Tom, I got a question, or maybe to kind of further to the discussion here. Last winter, I was talking about this technology with a grower here in southern Minnesota, and he happens to be in an organic system. So, not using any really any herbicides. And the big weed challenge that he's utilizing it for is giant ragweed, which, kind of creates that height separation between the crop and the weed pretty quick. But his claim was that he runs it kind of like you would do an inter-row cultivator. So folks that, don't have a lot of experience with that technology, you know, running it one direction is good. Going 2 directions, coming back the same way is even better. So he runs his electrocutor in the same kind of with the same kind of concept, and he's had good results evidently, and I just kind of want to get your take on, do you think there would be value with that second pass, and or is it unlikely to benefit? I don't know.
So that's a good question. So my work was done by my student Ryan Borgen, and in Ryan's experiments, we went one direction, we went back, so the same pass coming back, and then the third treatment was a second round. So you might think of one pass, 2 passes, or 4 passes.
Okay.
And we saw some benefit to going the second pass. We didn't see any benefit from going the second round. The other thing I want to say, and I think this is important, is the weed zapper is only 44 feet wide. So you're making a lot of tracks in the field. So going up and down or back and forth is going to create more tracks in the field. I would argue that you may also want to consider, instead of coming back immediately, maybe waiting a week or 5 days or 7 days, and making, getting some of the next flush of weeds, water hemp, that might be coming up into the canopy. So Myron is agreeing with me that second pass is very valuable, and he's calling out areas where there's a lot of weed pressure. I completely agree with that. Um, the second pass is beneficial. I would not advocate for the second round at all. I would rather that you wait 6, 7 days and then make a second application.
So, Tom, kind of staying on this thread here, someone asked, what effect the weed zapper might have if it was used to terminate cereal rye, which they don't indicate how much biomass and at what time, because it can vary quite a bit. With Eric's study, when you wait out till June, a winter cereal looks a lot different than it does in May,
Yeah.
and
So I want to reiterate what I said a few minutes ago. Grasses are very, very difficult to control. The weed zapper has multiple settings on it, which means that it's delivering more electricity. And I don't remember what the units are. Maybe somebody can help me. But that's a very energy intensive setting that you're using, and you're not getting as much translocation of electricity, if you want to call it that, as you would in a broadleaf species like water hemp. So I would be suspicious about the results that you're getting. And Ryan, since you brought that up, there have been people that have asked about defoliation as well. Can I defoliate my dry beans, or can pre-harvest aid on dry beans or maybe potatoes? And I don't have that experience either at this time, but that's something that people have asked about.
Okay, good. Uh, so there was one question, again, related to the weed electrocution. So we're waiting for this height differential with water hemp. Uh, you're going to see some interference with that crop, some potential for yield loss. If we had a ballpark, what kind of loss are you going to see if we're reliant on that technology if we fail to get control earlier, I guess?
Yeah, there was some work. I'm hoping Debalin or Eric can help me out. There was some work done at the University of Missouri, and they tried to quantify losses in soybean. We didn't do that in sugar beet. Debalin, by chance, do you remember what they found in that experiment? The researcher was Schreiber that did that work with Kevin Bradley. Do you remember those results?
Mm, yeah, I know which study you are talking about, but I cannot remember the result top of my head right now.
So let's do this, Ryan. When we do the written summary of this meeting, we'll try to pull that information out and put it into the report.
Excellent. Yeah, that'd be good. So, um, one last question here on the electrocution. What is the cost for a unit like that that's 44 feet wide?
Yeah, they're pretty pricey. I don't want to say a number because my number might be wrong and old. But it would be, I would say rounding off, it would be near $100,000.
Okay, excellent. So we'll kind of stay on that economics thread. We're not going to let Tom off the hot seat yet. So, Tom, we were having a discussion prior to the webinar starting today that we're kind of in a perilous decision-making mode right now with the current crop price scenarios and weed management. And I thought you made some good points, and I was hoping that you could maybe kind of cover the same material here with the audience. So
Yeah. So, everybody follows markets. I'm sure everybody on the line today knows what grain prices are. They could probably tell us what the grain markets closed in the markets yesterday for corn and soybeans. So I was visiting with our University of Minnesota um, economics group, and this was back in December, and they were mentioning that if you own corn ground, the break-even price on corn production is 370. Corn at 370 a bushel. If you're renting, it's 420. For soybean, if you own ground, it's 850, and if you're renting, it's 1020. So everybody that's on today is thinking about the budget. What can I afford to spend money on so that I can stay profitable in 2025? And I would say that you've got to be thinking about your weed management program. Why not? You've got to be thinking about everything. And why should the weed scientists get, special treatment? So the only thing I would say about that, or the one thing that I would say, is don't forget that weed seed remains viable in the soil depending on species multiple years. So grasses maybe 1 year, kochia 1 to 2 years, the pigweed species 4 to 6 years, lamb's quarter and common ragweed, and I'm not sure if giant's the same or different. I would say north of 10 years, maybe 10 to 20 years. So allowing weeds to go to seed in 2025 not only affects your yields in 2025, but it's going to impact some of the economics over the next 5 years, 10 years, maybe even longer. And I think that has to be a consideration as you look at your budgets. Of course, we want you to be profitable, but on the other hand, um, think about what the implications of not spending money in 2025 on future years.
Excellent. All right. Doug, I think we had that. I'll type it up. Tom, just remind me the soybean break even for owned land. What
Owned
was the
land
number?
was $8.50.
850.
And this
Okay.
is according to our team at the University of Minnesota. And then for renting ground, 1020.
Okay. Excellent. So a couple of things here. Let's see here. I know one thing that came up in our discussion ahead of the show here is that concerns about repeatedly relying on group 15 herbicides, and maybe we could have a little discussion around the use of group 15s and both as a pre and then as an overlapping residual. Uh, what are the concerns with that? Because we're really, particularly in the water hemp world, becoming quite reliant on that group of chemistries.
So I'm going to ask that Debalin take the lead on this. I'm going to come back in the second half with sugar beet because believe me, in sugar beet, we're very dependent on group 15s. So Debalin, if you don't mind, can you start the conversation and then I'll compliment you?
Sure. So, Group 15 herbicides are definitely very important for water hemp management, especially when you see that water hemp is becoming resistant to a lot of post-emergence herbicides. So we are losing a lot of post-emergence options. So to start clean and stay clean, we are relying heavily on Group 15 herbicides. Example, Dual, Warrant, Surpass, Outlook, Zidua. So those are the herbicides I'm talking about. And the point here is if you spray Group 15 herbicides, we know they work really good on small seeded broadleaves and grasses, and then you have the opportunity to come back with the same or the different name, but the same group of herbicides, that group 15s, as a post-emergent spray. So you can spray on the top of your soybean and corn, and that will give you a little bit residual in the late season. So that's we call the layering residual approach. So you have pre, then post with another residual herbicide. So that will give you like extended control for your, let's say, water hemp. But the problem is the there are two really clear problem. One is we are heavily relying on group 15 herbicides nowadays, and then it is not uncommon to water hemp to become resistant to group 15 herbicides because in Illinois, Indiana, they already reported that water hemp is becoming resistant to group 15 herbicides. So the key point here is if you are rotating your crops, corn and beans, and if you're only relying on group 15s for your residual water hemp control, maybe not a good idea. Maybe rotate that with some group 14s, group 5s, group 27s, so that like you have the diversity of sites of action for water hemp control. And then another issue recently, we got to know that MDA reported that overuse of acetochlor that caused some surface water contamination in southern Minnesota. So that means if we continue to rely on only group 15, especially acetochlor type product, we may see that more reports about surface water contamination and groundwater contamination from these herbicides. Then the problem will create is there might be additional restrictions on those use of those herbicides. We are already in the limiting situation for effective herbicides. So that's why I'm recommending, yes, group 15 herbicides are really helpful for water hemp control. And um, if you need to get like season long control, layering residual approach is really good. But maybe you can think about rotating the sites of action so that we don't develop the resistance as well as we don't contaminate our water resources. And also, when you rotate your herbicides, that will be good because maybe in the earlier in the season, in the pre's, you can use some group 14 or group 27 when there is a high chance of surface runoff or leaching due to the excess rainfall. And then you can save those group 15 maybe for the layering residual for your post-emergence application. So think about it. Like my suggestion is group 15 is very important herbicide, but don't solely rely on group 15s. Try to rotate. I'll probably
So I
stop
have
here for Tom. Yes.
I have just a couple of comments, Ryan, and then we can move on.
Okay.
So I would guess that our listeners today are growing soybeans, corn, wheat, and maybe there's some sugar beet producers on. I want everybody to map out their programs for how they're managing pigweed in their field, and do that across the rotation and demonstrate to yourself how many times you're using group 15 herbicides on that field across the rotation. So demonstrate that you're using 15s, demonstrate that you're using alternatives to 15s. So atrazine in corn is a nice example. Using the 14s in soybean is a nice example. We don't have any other examples in sugar beet, so we've got to use the 15s. That's all we've got. So do that exercise, demonstrate to yourself that you're rotating. Now, for some, you might say, well, Debalin's talking about Illinois. What happened in Illinois or what's going on in Arkansas isn't going to come to Minnesota or North Dakota. We're dealing right now in North Dakota with kochia populations that are resistant to soil applied group 14 herbicides. So herbicides like Sharpen and Valor. So resistance can occur with soil applied herbicides. That's not just a post emergence herbicide phenomena. So I think we've got to, think clearly about our decision making and making sure that we're using as many options as possible. And I want to reiterate what Eric mentioned earlier about cultural practices, using row spacing, using planting density, using planting date as a way of closing rows and using the canopy to shield late germinating weeds. In sugar beets, I love it when the canopy closes because that big leaf is stopping a lot of late germinating water hemp. So take advantage of the crop to help to reduce the pressure on weed control.
Yeah,
Ryan.
unfortunately for us, Tom, you've been sending some of that kochia to the south here. I've got a photo from I think it was Steele or Freeborn County with a multiple herbicide resistant kochia from this fall. Just not a good situation. But along that thread with the group 14s, and you were mentioning kochia, sometimes we see this or hear reports of herbicides, and I'm talking about pre-herbicides now, not lasting as long, right?
Yeah.
So,
Yeah.
so I'm curious if you guys have any comments on that because I think I don't know if that's a tip of the iceberg with some of these resistant issues, but where I would have expected 30 days of performance with a pre-applied with good moisture conditions, they may only be seeing 15 or 20. I mean, is that kind of maybe the tip of the iceberg?
Debalin, do you want to answer that?
Sure. So Ryan, so my colleague from University of Illinois and USDA, they did a study for on Roundup. So they took data for herbicide efficacy for last 25 years, and they found that the efficacy of Roundup is declining, and maybe the weeds are becoming, let's say, less tolerant. I mean, even if they're killed by 1x rate, but still, like, if you need like half the dose 15 years back, you need almost double the rate right now to kill those weeds. So weeds are becoming tolerant. So I believe that thing is definitely happening with other pre-emergence herbicide. If we continue to use that for a long time, especially the single chemistry, what happened with Roundup, definitely we are developing a natural selection there, and they're becoming naturally tolerant. And another thing is like unpredictable weather, because some year you are like in Minnesota, we are too dry, and then the pre-herbicides are not working as expected, and some other year it is too wet, so the herbicide is already like activated, and the activity is gone within a week or 10 days because of too much rain. So I believe that other factors are also playing the role in this thing when you are hearing that pre's are not working as expected. But I definitely agree that weeds are becoming tolerant to those herbicides over the time. Tom, do you
I'll
want to
be
add
I'll be
something?
I'll be
Yeah.
brief, Ryan, because I know we're running short. Um, Unfortunately, scientists like to be definitive before they make a statement. This is one where we're going to have to hedge a little bit. I've seen the same. I completely agree with Debalin, and our other weed science colleagues would say the same thing, that the early indications are the soil residual herbicides aren't giving us the 2 or 3 weeks of weed control that we normally expect. Can we definitively say that with research? Probably not, but we certainly have early indications that that's going on. Ryan.
Excellent. All right. Well, we're going to move to one last topic here before we have to shut down for the day. And we're going to miss a couple of the tools, actually. We're not going to have time to talk about them, but I thought we would maybe spend a minute or two talking about crop rotation and some of the importance. There was a comment related to that, or kind of a comment question in the Q&A box. But, what kind of role does a crop rotation, a more diverse rotation, or maybe a different crop sequence? Does anyone have ideas on how we might think about that in terms of managing different weed problems?
So I'll start on this and I'll let Debalin finish up. So I think our crops are our most important ally in helping us. And the reason I say that, so I'm going to just throw out some crops in a rotation. So I'm going to throw out wheat, corn, soybeans. Okay, just 3 crops. So the what I think we need to do is try to mix it up. Don't make it so predictable for weeds. And what that means is how we do tillage, how we fertilize, when we plant, the row spacing that we have, when canopy occurs. All of those features of our crops make it more difficult for weeds. And I think that culturally is a way of slowing down or controlling weeds, maybe incidentally. So some are saying, well, I plant corn and soybeans at the same time. Well, maybe you do. But still, I think there's a difference between our corn strategies, maybe drilled or corn in 22 or 30-inch rows versus 15-inch rows or drilled soybeans. So we accomplish some benefits with the rotation, and I think, like I mentioned, by making it more confusing for weeds. Debalin, anything to add?
Yeah, so I'll add two more points here. So if you rotate your crops, you can bring the diversity in the herbicide sites of action. So, for example, in soybean, we talked about group 14 as pre's, um, and then in if you rotate that with another crop, let's say corn, then you can bring in group 5 like atrazine, you can bring in group 27 like callisto or balance as alternate sites of action. So that will definitely help in slowing down the resistance evolution. And small grains, like there are several studies for last 50, 60 years or even more than that, they showed that small grains are really good in suppressing the broadleaf weeds like water hemp because or sometimes kochia because the broadleaf weeds, they don't like the dense canopy of the small grains, and the small grains like wheat can get the canopy developed pretty quickly compared to corn or beans. Sometimes that helps with the suppression of the broadleaf weeds. So yeah, I mean, rotation has a lot of advantages, as Tom mentioned, as I mentioned. So there is no doubt about that.
Hey, Devlin, one thing you brought to mind here is something that Jeff Gonzalez always used to say is that pick the herbicide in the crop where it has the most value. So with Roundup, it would have been sugar beets, and with
Yes.
HPPDs, it would have been the corn, and so on and so forth. And I think there's kind of some truth to that. And the last thing I want to mention is in southern Minnesota, we do, particularly southeast, south central, we do have some certainly some options with processing vegetables, and sweet corn has allowed some folks to really get a hand up. I mean, again, we're relying on some of the HPPDs for weed management, chemical weed management in those, but the planting date changes and the harvest date changes can really impact their weed control. And so it's something to think about if you guys are having difficult to control fields. It tends to be a pretty economical crop to produce because they write contracts and they compete directly with commodity corn. So something else I just throw out from personal
Hey,
observations.
Ryan,
Yeah.
I can't let you off the hook at all. I just got to throw out tillage.
Oh,
So
tillage, yeah.
don't forget about tillage. When you're preparing your seed bed, ask yourself, what is the purpose of this tillage? Am I preparing a seed bed or am I trying to control weeds? Because the strategy, if you're controlling weeds, is going to be different than just preparing a seed bed. And then the other thing I'll say is don't forget about the inner row cultivator. And I don't care what kind you have, if you're using three-tine style or more of the goosefoot style, the cultivator can still be a valuable weed management strategy.
Yeah, excellent points. We should have really taken two weeks for this or two episodes for this show, I think. Uh, Good points there, Tom. I do know one of our previous coworkers who used to like to side dress his corn with a cultivator, and so he was killing two birds with one stone with maximizing his nitrogen efficiency while killing some weeds at the same point. So good points. We should have had 2 weeks. Unfortunately, we're out of time today, folks. But I do want to make mention to thank again our sponsors, Minnesota Corn Research Promotion Council, as well as Minnesota Soybean Research Promotion Council.